Okay, let's talk about this print line call that ends with an exclamation mark. So in fact, that is not a function call, but print line is a macro. So every time we see an exclamation mark, that means that this is a macro and not a function call. So what is a macro? In short, macros are used for metaprogramming. This is a way of writing code that writes more code. That sounds super weird, but it is extremely powerful, as we will see in a moment. A function signature must declare the number and the type of the parameters this function receives. Like for example, our calculate function has to declare all of the parameters and their types. A macro, on the other hand, can be called with a variable number of parameters and with different types every time. That is very powerful. The downside of macros is that macro definitions are more complex than function definitions because at the end you're writing Rust code that writes more Rust code. This is much harder to read and to maintain. The reason why println is a macro is that it can receive a variable number of arguments. So it can be called like this with just a single string, but also it can be called with a string that contains curly braces. So every time println sees curly braces in the string, it will substitute them with values that we provide. Here, let's see this in action. So if we want to print a number, but we want to actually provide this number separately, we can put the curly braces and then we can give our number as a parameter to println. So now if we go to the console and we run our code, we'll actually see that println will output our number to the console. So that is pretty powerful. But also we can mix and match different types of parameters that we pass to println. So for example, we might also want to print a string here. So we put another set of curly braces and we put our string at the end. So now if we come back here, just clear the console, run it again, and we can see that println did output both the string and the number. This is extremely powerful. Like if we wanted to do this with a normal function call, like it would be impossible. To better understand how these macros are expanded into more Rust code, we can use a very cool tool called Cargo Expand. So Cargo Expand, you can find it on GitHub, is a cargo command. It can be installed by running cargo install cargo expand. And after we do that, we can go back to our console and we can just run cargo expand. So this will show us what all of the macros in our code are expanded into. So when we run that, we see our main function here. And now we actually notice that there is a lot more code than what we wrote. So all of this is what our println macro was expanded into. So here we can see the two parameters that we passed, and it's doing a lot of magic around that just so it can print it to the standard output. But instead of writing all of this code, we just had to write this nice single line of code. This is the power of macros. Now that we know how to print to the screen, let's actually print something useful. So what we would want to print here, like instead of these random things, would be our weight on Mars would be some number of kilograms, right? And then here we would just want to put the result of our function, and let's put 100 for now. So we can remove this function call, but for now this function just always returns 50. Over here, I found a nice website that actually gives us the formula for converting our weight on Earth into what we would weigh on Mars. So it is a simple formula. We just divide our weight by 9.81 and then we multiply the result by 3.711. So let's go back and actually change our function so it uses this formula. So we have our weight, so we divide our weight by 9.81 and then we multiply the result by 3.711. Okay, so we omit the semicolon at the end. This means that we return this statement. So now if we run this, it would actually convert 100 kilos on Earth into however many that would be on Mars. So let's see that in action. Now if we just do cargo run, we see that that is 37 point something something something. Sounds reasonable. We can actually go back to this website and check manually to see if we are correct. So if we do that here, we do get 37.83. So that is exactly the answer that we got. So finally, we have some useful code running. Now, what's left to do is actually read this weight from the standard input and pass it to our function.